Picture this, your grandmother has been in hospice for 3 weeks. The nurses are calm and professional and carefully non-committal about timelines. The doctors speak in ranges and probabilities, nobody will say the word. And then one afternoon, her cat, the fat indifferent Tabby, who has spent the last 11 years treating every human in the house as a minor inconvenience, silently walks into her room, jumps onto the bed, and doesn't leave. Not for dinner, not for the window, not for anything, he just lies down against her side and stays. She passes away the following morning. Your family talks about it for years afterward. What did he know? How did he know? Was it a coincidence? Was it something else entirely? And because grief is disorienting and the question feels almost too strange to say out loud, it usually gets filed away under one of those things. A story you tell at family gatherings, something you almost believe. But here's what I want to tell you today. That question, the one your family whispered about and quietly set aside, is one of the most rigorously studied, scientifically documented, and genuinely astonishing phenomena in all of animal cognition research. Have you experienced this with your own pet? Share your experiences on the comment section below. It is not folklore, it is not wishful thinking projected onto a pet. It has been observed in clinical settings, in wildlife sanctuaries, in hospice wards, in the open savanna, and in controlled laboratory conditions. And the answer, assembled piece by careful piece from biology, neuroscience, chemistry, and decades of fieldwork, is far stranger and more profound than animals just sense these things. So let's actually answer it, properly, with evidence. Let's start with an uncomfortable truth about how science has historically treated this subject. For most of the 20th century, the idea that an animal could perceive a human approaching death was categorized alongside astrology and seances as a thing that credulous, grieving people believed because they needed to believe it. The dominant scientific framework, behaviorism, insisted that animals operated on stimulus and response, input and output. There was no inner knowing. There was no awareness of mortality, their own or anyone else's. Death was a biological event, and animals had no cognitive apparatus that would allow them to represent it, anticipate it, or respond to it in any meaningful way. This was a reasonable hypothesis in 1920. By the 1990s, it had become a position that required actively ignoring a growing mountain of evidence. The first cracks appeared not in laboratories but in the field. Primatologist Jane Goodall, working in the Gombe forest in Tanzania, documented something that stunned the scientific community. A chimpanzee named Flint, after losing his mother Flo in 1972, stopped eating, withdrew entirely from the group, and died within weeks, showing no sign of physical illness. He was 8 years old and in full health. His death was attributed to what the research team could only describe as acute grief. He had perceived a loss so completely that it altered his biology. And if an animal could register the death of another this profoundly, the next question was unavoidable. Could they perceive it coming? That thread, once pulled, unraveled the behaviorist model entirely. To understand how animals might detect dying, you first need to understand what dying looks like from a biochemical standpoint. Because while the human mind processes death as an event, a moment, a crossing, the body begins its communication weeks, sometimes months in advance. When a person's organs begin to fail, even slowly, even silently, the body starts producing a fundamentally altered chemical signature. Metabolic processes shift. The liver and kidneys, as their function declines, change the precise cocktail of volatile organic compounds released through the skin, breath, and sweat. Ketones rise. Certain sulfur compounds increase. The chemical landscape of a person who is dying is measurably, detectably different from the chemical landscape of a person who is not. This isn't philosophy, this is clinical chemistry. And researchers have known it long enough that a legitimate and growing field is dedicated to using it. Not with animals, but with diagnostic sensors designed to replicate what certain animals appear to do naturally. Which brings us to the case that changed everything. In 2007, a paper was published in the New England Journal of Medicine as one of the most rigorous medical journals in the world, describing the behavior of a cat named Oscar at the Steerhouse Nursing and Rehabilitation Center in Providence, Rhode Island. Oscar had been adopted as a kitten by the facility and had no particular reputation for affection. He was aloof with visitors, indifferent to most residents, and moved through the ward on his own inscrutable schedule. But staff began to notice a pattern. Oscar would seek out specific residents, curl up beside them, and stay. Within hours, sometimes within a day, those residents would die. When Oscar was deliberately placed with a resident not in immediate decline, he left. He wasn't attached to any particular room or routine. He was attached to something else entirely. By the time the paper was published, Oscar had been present at more than 25 deaths. Consistently enough that staff had begun using his presence as an informal signal to call families in to say goodbye. The lead physician, Dr. David Dosa, was initially skeptical. After years of observation, he concluded that the cat's behavior was not random, not preference-based, and not explained by warmth, noise, or any environmental factor they could identify. His best hypothesis was olfactory. Oscar was detecting the specific biochemical changes of organ failure, responding to a signal the hospital's machines were not yet registering. Oscar continued working that ward for years. By some accounts, his total reached closer to 100 patients. No training, no instruction, just a cat alone with his nose and his strange loyalty to the ones the doctors couldn't reach anymore. Let's go deeper into the mechanism, because this is where it stops being a story and starts being science that should genuinely alter how you think about animal cognition. A dog's olfactory system contains approximately 300 million scent receptors, compared to 6 million in a human being. But more relevant than the raw number is the portion of the brain dedicated to interpreting those signals. The olfactory bulb in dogs is proportionally about 40 times larger relative to brain size than in humans. They are not experiencing a sharper version of what we smell. They are experiencing a fundamentally different relationship with chemical reality, one where odor carries the information density that our visual system carries. Researchers at the University of Pennsylvania's Working Dog Center have trained dogs to detect specific cancers, lung, ovarian, prostate, from breath and urine samples with accuracy rates between 90 and 98%. Cancers that were in many cases undetectable by standard diagnostic tools at the time. Let that settle. Dogs were detecting cancers that hadn't been formally diagnosed yet, operating upstream of medicine, and what they were detecting were precisely those altered volatile organic compounds. The body's quiet chemical announcement that something fundamental was changing at the cellular level. Now extend that. If a dog can detect a single cluster of malignant cells, what does advanced organ failure smell like to that same animal? What does the body's final metabolic shift announce to a nose 40 times more sensitive than anything we've built? The answer is almost certainly everything. Loudly, unmistakably. A 2019 study published in PLOS One trained medical detection dogs to distinguish breath samples from patients in septic shock, the systemic organ failure that frequently precedes death, from healthy controls. The dogs performed with accuracy above 95%. They were not reading behavior, they were reading chemistry, pure airborne molecular data that the body broadcasts whether it wants to or not. Now let's look at this from the other direction. Not from the animal detecting death, but from animals responding to it. Because across species, from the highly domesticated to the entirely wild, something consistent emerges. Animals register death in ways that suggest they understand its weight. Elephants are the most documented case. Cynthia Moss, who has studied the Amboseli elephant population in Kenya for over 5 decades, documented behaviors around death that simply do not fit any model of pure reflex. When a matriarch named Echo died in 2009, family members returned to her remains repeatedly over the following weeks. They touched her bones with the sensitive skin of their trunks. Young calves, who had no survival reason to stay, stayed anyway. Moss described one young female standing over Echo for more than an hour, unmoving, in what she could only characterize as vigil. More striking still, elephants have been observed responding to the deaths of humans they had known. A BBC documentary team filmed elephant behavior following the death of Lawrence Anthony, a South African conservationist who spent years rehabilitating traumatized wild elephants at his game reserve. Within 2 days of his death, before any public announcement, 2 herds walked 12 hours to gather outside his home. They stood there for 2 days, then left. His family reported the herds had not visited in over a year. There is no training that explains this. There is only the fact that somewhere in their neurological architecture, in the limbic systems they share with us, they registered something. Something shifted and they moved toward it. The elephant is compelling because it is well studied, but the phenomenon extends to species we'd never think to include in this conversation. In 2014, a pod of sperm whales in the Azores archipelago was observed by researchers from Whale Watch Azores exhibiting unprecedented behavior. They had formed a tight circle around a single, visibly ill juvenile, taking turns surfacing with it, essentially keeping it above the waterline so it could breathe, for several hours. The whale died. The pod remained with the body for over an hour before dispersing. Sperm whales are not known for this. It was documented, photographed, and published, raising a question the marine biology community is still working through. Did they know the juvenile was dying? And if they did, what does it mean that they stayed? Closer to human experience, multiple hospice facilities in the United States, beginning in the 1990s, began incorporating equine-assisted therapy programs. What staff noticed, independently across programs with no coordination between them, was that horses behave differently around patients in final decline. Quieter, slower, more likely to stand still in a way that is not typical equine behavior, not trained into them, observed, reported, and eventually collected into a pattern that researchers in anthrozoology began taking seriously as a clinical phenomenon. Now here's where we have to be honest, and I think you deserve honesty more than a satisfying narrative arc. Science can measure behavior, it can map neurochemistry, it can document accuracy rates and cortisol levels. What it cannot do, and this is not a failure of science so much as a structural limitation of inquiry itself, is tell you what it is like from the inside. When Oscar curled up next to a dying patient in Rhode Island, was there something we'd recognize as awareness behind that? Something like compassion, something like sorrow? Or is it a sophisticated chemical detection system producing a behavioral output with nothing we'd call experience behind it? Philosophers call this the hard problem of consciousness, and it is genuinely unsolved. We cannot verify subjective experience from the outside, not in animals, and not even in other humans. We infer it from analogy. But here is what I'd offer anyone reaching for pure mechanism as the complete answer. The limbic structures associated with grief, with empathy, with the registration of loss, they are present in elephants, horses, dogs, and whales. The behaviors we observe when animals encounter dying or death are not random. They are targeted, context-specific, and they appear across wildly different species with no shared social structure or evolutionary history with us. When something walks like empathy, responds like empathy, involves the same neural structures as empathy, and produces the same outcomes as empathy across hundreds of documented cases in controlled conditions and field observation, the burden of proof shifts. You are no longer proving it is something meaningful. You are explaining, against all of that evidence, why it somehow isn't. There is one more thing worth saying, and it doesn't live in any journal. When a person is dying, really dying, the human world often becomes strangely loud. There are logistics, there are phone calls, there are people managing their own grief in ways that sometimes crowd out the person at the center of it. There are the right things to say and the wrong things to say, and 1,000 small failures of presence in a moment that asks more of us than most of us know how to give. Animals bring none of that noise. When Oscar climbed onto that bed in Providence, he didn't come with a prognosis or a platitude or a form to sign. He just came. When those elephant herds walked 12 hours to stand outside Lawrence Anthony's home, they didn't explain themselves. They arrived, stayed, and left when they were ready. When a horse stands quietly beside someone the rest of the world is already beginning to let go of, it isn't managing the situation. It is just there, warm and slow breathing, and completely without agenda. And maybe that is the deepest thing this research points toward. Not just the extraordinary fact of animal perception, but what that perception moves them to do. The animals most capable of detecting death are not the ones who flee from it. They are the ones who come closer, the ones who stay, the ones who, without language or ritual or any of the structures humans build to make mortality bearable, seem to understand something we spend our entire lives trying to articulate. That the moment asks for presence, not answers, just presence. So do animals know when a human is dying? Yes. The evidence is specific, cross-species, and clinically documented. Dogs detect the volatile organic compound changes of organ failure with the same precision they bring to cancer detection. Upstream of medicine, upstream of diagnosis. Cats like Oscar build behavioral patterns around dying patients consistent enough to serve as informal clinical signals. Elephants register the deaths of humans they have known and travel to mark them. Horses shift their behavior around patients in terminal decline in ways that staff across independent facilities noticed, reported, and eventually studied. Whales hold vigil over their dying. And some of these animals, when they find us in those final hours, don't just know. They come closer. They stay. They offer the one thing no medical training can manufacture and no technology has replicated. Undemanding company in the hardest room. Your grandmother's cat didn't choose that bed by accident. He chose it because his body, shaped by millions of years of sensory evolution, told him something the monitors in the hallway hadn't registered yet. And then, because he was a creature built for presence in a way we perhaps once were and slowly forgot, he stayed. That is not a coincidence. That is not sentiment. That is one of the most extraordinary things happening in rooms all over the world every single day in the quiet hours just before the last breath, and almost nobody is paying close enough attention. There's always another incredible story around the corner. Hit like and subscribe to see what comes next.